Everyone, welcome back to my YouTube channel, and the question for today is prefix and suffix search. So the question says that design a special dictionary which has some words and allows you to search the words in it by a prefix and a suffix. So let's see what does it mean. So basically we have to implement this class wherein there are two functions, that is word filter and it initialize the object and the words in the dictionary. Basically we have to form the dictionary from the words that are present in the word filter. All right, so a string of an array of strings would be passed like this, like with containing different words like apple, ball and stuff like that. And another function we have to implement, that is f, which where in which we have given a prefix and a suffix. All right, and we have to return the index of the word in the dictionary. So the apple occurs at 0, say pen occurs at 1, so 2. So we have to return these indexes, and yeah, and if there is one or more than one valid index, so we have to return the largest of them. All right, so basically we will return the largest of them, that is okay, I'll tell you how. Let's see, I hope the problem statement is clear. Let's see for the example what we have over here. So the example given to us is, in the word filter the only one word is inserted, that is apple, and for function f we have to search for f, a and e. So output is 0. Why output is 0 doesn't mean it doesn't exist. It means that the first word, that is the 0th word, contains both the prefix and suffix. So for apple, apple, the suffix is a and the prefix is a and the suffix is e. All right, so yeah, so a and e both are occurring and it's present at the 0th index of the dictionary, so the answer is 0 over here. All right, that doesn't mean that it doesn't exist. Yeah, it's given over here that we have returned 0 because the word is present at the 0th index. I know the example is kind of a bit short but not too clear. I'll when we'll discuss the approach, I'll explain it in more detail, but I hope this example given to us is clear. Just think that only don't apple wouldn't be present, but there would be many words that can be given to us for the dictionary. All right, now let's see the moving on to the constraints part. All right, so the word dot length, that is the words that would be given to us for the dictionary, could be from 1 to 15,000. So there would be one word, there can't be a zero word, and so the check for that is gone. So basically we will get one word side like this. In case the above example we get one word, that is apple. Right, yeah, and a particular word could be maximum to the length of 10. All right, so basically in the dictionary words we are getting some words and a particular word length would be from 1 to 10. All right, it can't be empty as well. All right, yeah, and the prefix length would be 1 to 10. What does it mean by that? Is prefix length is, suppose for apple, ap is the prefix and le is the suffix, so we can be given aple, we can given as apple, and basically el like that, app for both the prefix and the suffix, because that doesn't match over here. All right, I hope the example is clear and this point is clear as well. And at most 15,000 calls can be made to the function f, so we have to implement it like that. I hope the question is clear. The best intuitive approach to seeing this kind of question is try only, but it for prefixes only, tries for prefixes only, as we know. And yeah, but for this also we will also implement it with the help of try, but we will do some little bit of modifications, and yeah, that all we will discuss in the approach of that problem. All right, I hope it's clear, and yeah, I hope the question is clear, that how the question will be there. So le will be the ap and le, this can also be the case. ple and ap can also be the case. All right, so the lengths both can matter, but there will be some length. All right, and the function calls can be made up to 15,000, so we have to implement it like, very smoothly, like minimum. So best way for searching and optimization, and since the word length are given like this, so hashing cannot be used, hashing, because it's difficult, and only the this could be used. And also it consists of lowercase English letters, so that make the use of try very easy. And I hope the question is clear. Let's see how we are going to solve how we are going to approach this problem. All right, so let's see how we are going to solve this problem. One thing for the approach that is clear is that we will be using try. All right, and yeah, but the question also contains the we know that how to calculate for prefix. It's a very simple example and it's a basic application of try as well. No need to go in that detail, but we have prefix plus suffix. So how we are going to implement it? All right, now let's see the approach. All right, so one thing is clear, that is that we will be using a trie data structure to store. If any of you is not knowing what is the trie data structure, is this kind of an array tree used to store strings. So basically it has two representation as well. We are going to use array based representation. I tell you why, because it consists of the lowercase letters and we have to do the searching more fastly, because it's saying that 15,000 calls can be made at one time. So to make the searching faster, array approach is used widely. So yeah, I hope that's clear, and do check out the video. I've made one video as well on trie and representation, and you can check that video as well. That will help you with the basic structure of trie and where to use array approach or the map representation. I hope that would be clear. Now moving on, we will be using trie over here. All right, now let's see how we are going to solve it. All right, so give an example. See apple, and suppose there is a word bag, there is a word cat. All right, so these are the words present in 0 index, 1 index and 2 index, and we have to return the largest index. All right, so I hope that's clear as well. So basically for the first word apple, how we are going to sort it, because if we add this to the memory, and for the search we have to search like e, suppose LE and AP, we have to search this because AP is the prefix and LE as a suffix. So we have to search this. All right, so what the approach we can use? If it's a general try, simple try, then we'll search for AP. Yeah, we got it. And for the same word we have to go to N and we have to search the LE as well, but that would make the question very difficult. So what the new kind of approach we are going to use is, we are going to use some pair approach. All right, one pair approach could be used. So what I think is that if, because the letters length is 10, all right, it's given, it can't be like more. If in case it's more, I think this approach couldn't be used, but since the length is 10 only, then can we use it like this? Like if we store apple twice and making one one exception, one keyword or one anything, because we know it contains only lower letter words, so we can use any kind of word to mark it as a common point. That will tell is that we are repeating the word. Why? Because now we will have to search for AP LE and we will combine it like this, LE AP. Now we will search for this in the string. All right, why we are using this approach? The question remains still, why we are storing it again and again? Because we have to make the faster search algorithm rather than the storage one. So we can compromise here on a little bit on storage. All right, and it's not a big compromise, because the length of the words that will be given to us would be from 1 to 10. It can't be like 1 to 50 or 1 to 1000 or 1 to 10,000 word can be given, but it would be 1 to 10. So if adding it double, like we're making 20 in max case, in the worst case, so yeah, it doesn't harm our space complexity as well. All right, I hope that's the point clear. And now if we store this like in our tree and we search this as a simple word containing these letters, then it would be a very easy job for us. Also, apart from searching, what we have to implement here is that we have to return the index also, and if there are collisions we have to return the maximum index. So what we are going to do is, when we are implementing this trie structure, we are storing word by word. First we will store the obviously word at 0th position, then 1 position, then 2nd position. So we will take some kind of in the trie node structure, we will use one thing called as weight or anything to store the current index where it's stored, and it would be updated accordingly. All right, because the words keeps on inserting and it would be updated, so obviously it would be largest only. So that thing also solves our problem. I hope the approach is little bit clear, and why we are taking it twice. I know some of you might be thinking it will take extra space will exceed, but no, we are given that the length would be 10. So we can use this kind of approach. Had it been simple prefix, then we can do this. Had it been simple suffix, then we can reverse it and store it in the trie as well. But the case here is that we have to find both of them. So how both of them? If we store them twice and insert a special character that tells us that the word has ended. Alright, and this is a special character. So basically we will take the word that would be given to us from the dictionary apple has. So the words array, the words string. So for apple, and we will insert this. Alright, now we will try to insert apple this and apple in the map. And of course, if we are using this as a special character, so we have to hash this as well. Alright, now for this hashing, it's simple. We can use the 27th character. It has a 27th one. Alright, basically when we use for small letter, everyone must know that we take the trie node array size as 26, because we know there are 26 letters in the English alphabet 0 to 25. Now we are adding this one letter on our own, the special character. So for this it would be 26. I hope this is also clear, and every doubt is clear, every approach is clear, even the question is clear as well, because the question seems to be a little bit tricky in the first read, and the example was also not clear. But I hope the question is clear. And also this thing is very important. Suffix can be like this. Alright, it won't be like a and e and words like that. It can be a bigger player, it can be the word itself. Alright, in the prefix as well as the suffix. Alright, I hope this is clear, the approach is clear. Basically it's a very important question, and it actually revises a lot of concepts of the tries as well, from insertion to as well as searching. Alright, so and we have to optimize the searching, so this is the best approach according to me. Alright, I hope the approach is clear. If any of you are still facing any kind of difficulty, I think it will be clearer when we see the code for it. Alright, so yeah, let's move on to the code and see. Yeah, so here is the code, and first this is the structure. Basically obviously children we have in the array, we declare them to memory is 27. Why 27? I have told you. Initial weight would be 0 only, and yeah, how this is the structure of a trie. Alright, now moving on to the main part. Alright, the main part is how we are going to store it, because we are going to store it once on the word.len. Now this will make 15,000 call, not this. Alright, so don't keep it in mind that words can be inserted again. It would be inserted at one, and again calls can be made. Alright, I hope this is clear. And we have to optimize it, and the best optimization is like this. So let's tell me this also first, that how we are making suffix plus prefix and the special character that we are using here, and then we are going to search it. If it's searched, then we are going to just return the weight, and how the weight would be largest, that I also told. Alright, I hope this is clear. Now moving on to the main part, that is how we are going to store it. Alright, so basically we initialize the node and we take the length, that is the string of array of strings that is given to us. Alright, we picked first word, and this is the first word plus this. Alright, IPPLE star. Now we are going to insert APPLE again. So let's see how we are going to do it. Alright, now moving on. So the word is till now is this. Alright, we will use a mathematical formula, we will not take it as twice. Alright, now let's see. Alright, now for int I equals to 0, enter word.length. Word.length would be changed, it would be plus this character and I plus plus. Now we it's simple of trie insert operation, and we will simply update the weight. Alright, now for j equals to I, the y is less than 2 dot word dot length minus 1. Alright, because we are going to insert it again 2 times, but for this we are not going to, so it would be APPLE, this APPLE. So this would be again twice, but up to here only, so that is why minus 1, and that is a simple insertion operation for a trie node. Alright, and the weight would be updated likewise. I hope this code is clear to everyone. Now it's just like the approach that I will discuss, just it's done in little bit of coding technique. If the approach is clear, then the code should be cleared as well. There not to be any difficulty in it understanding this. So let's try to submit it. So as you can see, it's accepted. So if you face any kind of difficulty, I know it's a tough question, but if you're still facing any kind of difficulty, please feel free to reach me in the comment section. I'll surely reply to every one of you. And if you really like this video, please press the like button, share it among your friends, and subscribe to my YouTube channel. Thank you for watching. Bye.